Okay everybody, this is a video on Avogadro's number. By this point you should know how to do calculations using molar mass, converting from grams to moles, and from moles to grams, because with Avogadro's number we're adding one step to that process. So first of all, you should know, what is Avogadro's number? You actually already know what it is. Avogadro's number is 6.02 times 10 to the 23rd. That's Avogadro's number. So 1 mole is Avogadro's number. Now the one addition that we have to the problem here using Avogadro's number, 6.02 times 10 to the 23rd, is the fact that 1 mole of any element, which could be like carbon, nitrogen, oxygen, any mole of any one element, or of any compound like sodium chloride or water or any other compound you can think of, nitrogen dioxide, what have you, has exactly 6.02 times 10 to the 23rd atoms. What that means, if I was holding 1 mole of oxygen in my hand right now, that would mean I was holding 6.02 times 10 to the 23rd oxygen atoms. If I had 1 mole of salt, which is NaCl, if I had 1 mole of salt, then I would be holding exactly 6.02 times 10 to the 23rd atoms. So with that information, we should now be able to convert from grams. If I told you I had 32 grams of oxygen, we should be able to convert all the way to atoms. Now let's do an example right here. So I have 32 grams of oxygen. So the first thing I do is set up my picket fence. 32 grams oxygen. Now you should know already how to get from grams to moles, right? We want to end up with 1 mole right here. So what is the molar mass of oxygen? Because that's what we would want to put here below 1 mole. We look at our periodic table, we see the molar mass of oxygen is 16 grams of oxygen. That's our molar mass. So let's see what we've done so far. We've canceled out grams, boom and boom, and we are left with 1 mole of oxygen. Now we don't want to end with moles, right? We want to end with atoms now. Therefore, we need to cancel out moles. How can we cancel out moles? Well, we can just put 1 mole right here. That's easy enough, right? 1 mole, by putting 1 mole right there, we have canceled out moles. And what do we want to end up with right here? We want to end up with atoms, right? We're trying to go from grams to atoms. Therefore, if we look back up at our notes right here, 1 mole of any element or compound has exactly 6.02 times 10 to the 23rd atoms. So 1 mole has exactly 6.02 times 10 to the 23rd atoms. So right there, and then we are ending up in atoms. So we've gone from 32 grams to moles and now to atoms. And so that is going to be how you calculate using Avogadro's number. And then you would just multiply straight across. Don't worry, I'm back. Okay, you would just multiply straight across, meaning you would do 32 times 6.02 times 10 to the 23rd, and then you would divide that by 16. Your final answer ends up being, for those of you that calculated that and you need to check your work, it was 1.20 times 10 to the 24th atoms oxygen. So that would be your final answer. When you're calculating atoms, you're always going to end up with like an exponent right here, like scientific notation, because it's always going to be a pretty big number because you're multiplying by Avogadro's number there. So that would be your final answer. Let's do a couple more examples. Okay, if we start off with 96 grams sulfur, set up our picket fence here. First thing we got to do is convert from grams to moles. So we got to find out, we want to end up with 1 mole right here, right? So we have to know the molar mass of sulfur, which is 32 grams sulfur. So we have arrived at moles, we've canceled out grams, we've arrived at moles. Then we want to go from moles to atoms. So we would just put 1 mole right here. And then 1 mole has how many atoms? Every single mole of everything has how many atoms? 6.02 times 10 to the 23rd atoms. Therefore, sorry that kind of went down to the bottom, that's alright. Therefore, we've canceled out moles, and all we are left with is atoms. And then we just multiply straight across. 96 times 6.02 times 10 to the 23rd and then you would divide that by 32 because that's what we have on bottom. You end up with 1.80 times 10 to the 24th. 1.80 times 10 to the 24th atoms of sulfur. Okay, 2 more examples if you need them. Okay, 80 grams neon, it's the same process. Try to solve this one yourself. Pause it, try to solve this one yourself. Okay, hopefully what you did is you looked and you saw that the molar mass of neon is about 20 grams of neon, and that would equal 1 mole. Whoops, not exclamation part mole. 1 mole right there. We're going to have to delete this, get this out of our way here. Okay, 1 mole. And then we would put down here, we would put 1 mole. 1 mole is 6.02 times 10 to the 23rd atoms. There you go. And then we see that we've crossed off grams, crossed off grams, crossed off mole, crossed off mole. Go ahead and solve it yourself. You would do 80 times parentheses 6.02 times 10 to the 23rd. And then we would, 80, sorry, times 6.02 times 10 to the 23rd. You get 4.816 times 10 to the 25th, and you would divide that by 20. Your final answer, 2.40 times 10 to the 24th. Okay, last one, do this one yourself. I'm just going to show you the answer at the end. Do this one yourself. Okay, so if you had 3 moles of oxygen, and you'd have 3 moles, you'd have a picket fence, you'd end up with 1 mole of oxygen down here equals 6.02 times 10 to the 23rd atoms. Ha! Surprised you on that one. It was a little different. We got to skip one step because we didn't have grams. So you just go directly from 3 moles of oxygen to 1 mole of oxygen having 6.02 times 10 to the 23rd. My bad, I didn't put atoms. So all you would do is have to cross off moles and then multiply 3 times 6.02 times 10 to the 23rd. And that ends up giving you 1.806 times 10 to the 24th. So you got to skip a step there. That is how we convert to atoms using Avogadro's number. There's 4 examples there. We had 3 on this page, 1 on the previous page. Reference those as you work today to convert using Avogadro's number. Good luck. Farewell.